Somewhere in the pursuit of internet spectacle, the concept of a meat lover's pizza escalated into this: a tower of exactly 1,000 pepperonis, stacked directly onto a single slice of cheese pizza. This phenomenon is a fixture of the modern web, dominating communities like Reddit's r/pizzacrimes, and serving as a high-calorie endurance test for YouTube's most ambitious competitive eaters. These videos prioritize raw volume, but the culinary world operates under a much stricter set of rules, dictated by thermodynamics and material strength. Once those natural limits are breached, the pizza becomes a catastrophic structural engineering failure. To understand exactly why the stunt pie fails, we have to establish the normal engineering limits of a pizza crust. This matrix is the Burke Corporation Pizza Topping Portion Guide. Pizzerias use this specific data to calculate the exact weight a crust can handle before the bake cycle fails. According to the guide, a standard 16-inch pizza is engineered for 24 to 32 slices of pepperoni. Even the maximum heavy load tops out at 48 slices, a total weight of 3 ounces. This chart compares that 3-ounce baseline against the viral stunt. 1,000 pepperonis weigh 8 pounds. Multiplying the intended load by a factor of over 20 turns a standardized recipe into an impossible physical equation. The first point of failure happens the moment this stack enters the oven, creating a thermodynamic blockade. Proper baking relies on extreme ambient heat. An oven operating at 500 degrees Fahrenheit is designed to rapidly penetrate the pie, cooking the dough, boiling the sauce, and melting the cheese simultaneously. Piling 8 pounds of dense meat on top of the dough overrides the intended thermodynamics of the cooking system. In this thermal cross-section, the meat mountain acts as an insulator. It deflects heat away from the center, blocking it from reaching the base. Consequently, the top layer burns while the cheese remains cold and the dough stays completely raw. This thermal failure is so severe that competitive eaters often use pre-cooked pepperonis to bypass the physics of the oven entirely. Extreme vertical density prevents a standard oven from baking the pizza through to the center. Even if the dough could cook through that blockade, the stack still faces the problem of fat rendering and trapped moisture. Pepperoni is extremely rich in fat. Heating 8 pounds of it at once releases a massive, unstoppable quantity of hot oil. Because the vertical stack is tightly packed, the moisture cannot evaporate into the air as steam. Gravity forces that hot liquid downward into the crust. To bake into a firm structure, dough requires a precise ratio of water to flour, typically a hydration balance between 65 and 68%. This saturation model illustrates the damage. The downward flood of grease and trapped vapor oversaturates the dough, causing it to swell into a gummy paste. This leads directly to the final physical limit: mechanical collapse. A standard slice relies on a baked, rigid bottom to provide tensile strength. It is engineered to carry 3 ounces, not to serve as a load-bearing foundation for an 8-pound cylinder. The combination of moisture saturation and excessive weight makes a total structural collapse inevitable. Real chefs maximize pepperoni flavor by engineering around these physical constraints. One solution is par baking, where the crust is baked alone to fully set its rigid structure before heavy toppings are added. An even more ingenious historical solution to the grease problem comes from Canada: the Windsor-style pizza. Rather than layering whole circles of meat, Windsor pizzerias shred their pepperoni. This comparison diagram shows the physical advantage. Shredding maximizes surface area and leaves thousands of tiny gaps, allowing moisture to vent as steam instead of saturating the crust. Maximizing meat density is ultimately a problem of surface area and ventilation. The 1,000 pepperoni pizza acts as the ultimate cautionary tale in culinary physics. A high-performance pizza relies on a precise balance of heat, hydration, and weight, rather than raw volume. Mastery of these physical boundaries defines a world-class pizza.